Hello, welcome to our Design Expo video on our senior design project. We are the Lansing Board of Water and Light Distribution Protection Coordination Team. We have 5 members on the team and 2 of them are here on this video, Marleigh and Jared. Before we dive into the specifics of our project, we wanted to talk about the impact and motivation of our project. As a consumer and utility customer, you are a part of the distribution system. This is where power is delivered or distributed to various loads and customers. When there is a fault on the line, that means the power is going somewhere it shouldn't. Faults can range from temporary, where your lights blink off and on again, to permanent. Your lights may blink, then go out, or lights go out immediately. Our project was looking at ways to minimize the impact of faults on customers, minimize the damage done to the power line, and decrease the costs in the aftermath of a fault. An example of a permanent fault is when a whole tree falls on the power line, as shown in the picture here. There is significant damage done to a power line and coordinated devices where using technology and communication won't fix the power line. The other type of fault is temporary. An example of this is a tree branch falling onto the line. The high current caused by the fault burns away the branch, and once it's burnt away, power would be restored if other damage wasn't caused.
Given those examples of the fault types, our project scope is to implement a distribution plan through new devices and new coordination of devices to minimize the impact of faults on customers and to minimize financial losses. This was done through research to update our sponsors' methodology and philosophy for protection schemes, research into distribution automation, this is the smart technology and communication to operate devices, and a cost-benefit analysis using device costs, case studies, and outage data from an interruption cost estimate calculator. Deliverables for our project are a methodology and philosophy for protective devices report, a distribution automation report, and a recloser case study where outage calculations were found and a cost-benefit analysis were completed. Shown here on the slides is the simplified one line of the sponsor-provided circuit. It shows lumped customers on the line with various fault locations. This one line was used throughout the recloser studies to better understand the impact of faults on customers. Based on the team's research and the results of the case studies, it is our recommendation that our sponsor implement automated switches when creating a connection between 2 isolated circuits. In the case of an outage, one circuit would be able to support the other with the fast closing of the switch. This would reduce the response time and outage expenses. The other recommendation would be to implement a midpoint recloser within the circuit to better section the healthy and unhealthy portions of the system when a fault occurs. In conjunction with the automated switches, the healthy part of the system would be restored. As we wrap up this video, we want to acknowledge our team members who contributed on this presentation and the video. We would also like to thank our advisor, sponsor, and other ECE members for their contributions throughout the course of this project. Thank you.